Hey everyone, Professor Sebastian. Welcome back to our statistics class notes. We're finally moving into Chapter 6. Chapter 6 is about modeling random events, and we're going to be talking at what's called the normal model, or the normal probability distribution. So the main topics in this chapter are distinguishing between discrete and continuous random variables, and then applying a normal model to find probabilities. Notice I have crossed out the binomial model and applying a binomial model to find probabilities, as this is covered in section 6.3, which is we will not be covering it. It is simply not necessary for you to understand chapters 7, 8, and 9, so we're going to skip that. All right, so here in section 6.1, first thing we need to talk about is a probability distribution. What is a probability distribution? And to distinguish between discrete and continuous random variables, and to use probability distributions to compute probabilities. So, probability distribution is a tool, a table, or a graph. Sometimes that's called a spike graph, but don't worry, the name's not important. That tells us the following. One, it has all possible outcomes of a random experiment, and two, it has the probability of each outcome. So there are two features of a probability distribution. First of all P of x, all probabilities of x, whatever x is, values must be between 0 and 1 inclusive. So we already know that about probabilities. They must be between 0 and 1, and they can be 0. They can be 0 if that event is never going to happen, and they can be 1 if it's certain to happen, but anything in between. And then the sum of all the probabilities, all the probability values for our probability distribution must equal 1. That's because it's supposed to take into account every single thing that can happen. So, for example, consider the random variable x such that x equals the outcome of rolling a die. And we want to give the probability distribution for this random variable. So x is the outcome of rolling a die. So if I put x here and below it I put p of x, first of all what we're going to do is we're going to list every possible outcome of rolling a die. That's the values that x can take on, which are 1, 2, 3, 4, 5, and 6, of course. And then the theoretical probability of rolling any one of these outcomes for every x. So if x is 1, that's the outcome of rolling a 1. That's 1/6. If x is 2, it's 1/6. If x is 3, it's 1/6, etc. You've seen this a few times now as we've been talking about probabilities. But this is what's called a probability distribution, where we list every possible outcome. Now, it's going to be important to understand that this is what's called a discrete random variable, and I'll talk about that in just a second. If we have a continuous random variable, it wouldn't be possible to list every outcome. But if we can list every outcome, that's called a discrete random variable. And then we list the probabilities below them. So what is the probability of rolling a 5 or a 6? So that's mutually exclusive, right? We can't get both a 5 and a 6 at the same time. So in that situation, we want the probability that x is equal to 5 or x equals 6. Since these are mutually exclusive, then it's just add up those two probabilities. Probability x equals 5 plus the probability that x equals 6, which is 1/6 plus 1/6, 2/6, or a third.